In this video, let's learn more about Require Auth flag and how to remove a trust line between an user account and an issuer, wherein the user account has been authorized to hold the balance of an issuer using a setAuth TrustSet flag. Many people believe that if an account has Require Auth flag, nobody can establish a trust line with that issuer. That's not true. Anybody can still establish a trust line with the issuer but can't hold the balance issued by the issuer unless authorized to hold it. Okay, so let's see how it works. Create two accounts, an issuer account and a user account. On the issuer account, please enable default ripple. Do it right now. Enable default ripple. And then also enable Require Auth flag on the issuer account. I'll do the same. Please follow along with me. Now I have enabled default auth and require auth flags on my issuing address. I'll have two secret keys here, one for the issuer and one for the user. Let us derive the account for issuer and user using those secret keys. So I have the user. Let me copy the issuer secret. Next, let me copy the user secret. This is user secret. Okay. I'll execute account info command on the issuer address and show you the flags enabled on the issuer. The issuer address is present inside issuer.address. And then we have a package called flag names. This one, I have already installed the package. Let me change this, extract only the field account_data. And let's look at the output. So as I said before, I have already enabled default ripple and require auth flags on my issuing address. Now let me remove this. And let me use the user account here to fetch the user account's current sequence number, and then let me write the payload to set up a trust line with the issuer. So transaction type is TrustSet, account, its user address, which is present inside user.address, fee, 10 drops is okay as it is testnet. You have to fetch this information from the ledger. Flags. So let me get back to the documentation, and we need to set no ripple flag while setting up the trust line. So let me copy this. Now the limit amount, which is an object. So we need to specify the currency. I'll specify it as XTP for no reason. Issuer, we have the issuer address inside issuer.address. And a value of 100. That's the limit, the number of XTP the user is willing to hold. And the sequence number account_data.sequence. So that's the payload to set up trust line with the issuer. Let us sign it and just extract this field, that is signed transaction. Let me sign this payload using the user account Don't confuse here, it has to be user account, because user is setting up this trust line with the issuer. So let's submit this signed transaction to RippleD. The command is submit tx_blob, assign the value of signed transaction to it, and let's output the result. Okay, it is successful. Let me comment out everything here and then check if the trust line has been established using account lines command. account_lines on user account user.address. Yeah. Hope you are following along and coding along with me. Now, as you can see, this is the issuer address, this is the user address, and there is no balance, zero balance. The currency is XTP, the limit is 100, and you don't see any authorization field here. Okay, but we have a trust line set up here. So now, since we already have a trust line, let's try to send some tokens to that user account. So this is the issuer account. I had previously changed it already. So now let's try to send some XTP to the user account. Remember, this user account has not been authorized to hold any of the balances issued by the issuer. Let's see how it works. So let's send XTP from this issuing address to the user's R address. I'll send one XTP. And as you can see, the transaction fails with this message, path could not send partial amount. Path is dry, there is no path. Okay, so let me get back here. Let's authorize the user account to hold the balance issued by the issuer. So we need to execute this from issuer end. So let me comment this out first and remove these comments. And one more thing I want to show here is, since user established this connection, the user is not in default state with this on this trust line. So user pays for the reserve and issuer does not pay for the reserve here. Only if user is in default state, issuer has to pay for this trust line because issuer has authorized the user to hold the balance. In this case, user is not in default state, so user pays the owner reserve. So from issuer end, owner count is still 0. So let's check this back once again after authorizing the user account to hold the balance issued by the issuer. So now the account signing this transaction is the issuer. So we need to authorize the user using this flag. Let's replace this. The account is the issuer account. The issuer address should be changed to user address, and we don't need any balance here, so let it be 0. That's it, I guess. So we are fetching the sequence number from the issuer address. Looks like everything is fine. Transaction public key is not authorized. I think we are signing it with the wrong keys. Yeah, we are signing it with a user account. We need to sign it from issuer account. This one. We have to sign it with issuer's private key. So this should solve the issue. Let's check that. Let me execute it one more time. Yeah, this time it's successful. Now the issuer authorized the user to hold the balance issued by the issuer. So let me comment out. Let's check the owner count once again for the issuer. It has to be 0 again because user is not in default. Yeah, owner count is still 0. Even though issuer authorized a user, still the owner count of the issuer is 0. That's because user account is not in default state with this issuer on this trust line. So let's get back account lines of the user, not the issuer. Now you can see a field called peer_authorized. That is, it's a setting from issuer end. Still issuer doesn't pay any reserve for it because user is not in default state because user established this trust line. Now let's switch to index.ts and send some XTP to the user account. Now this time the transaction should be successful as the user is authorized to hold the currency issued by the issuer. Let's check that. Okay, as expected, this transaction was successful and now the user is holding 1 XTP. Now let's get back to the TrustSetFlags documentation and see if we can unset this setAuth flag. As you can see, there are no flags to clear this setAuth flag. Let's read this. The auth flag of a trust line does not determine whether the trust line counts towards its owner's XRP reserve requirement. However, an enabled auth flag prevents the trust line from being in its default state. An authorized trust line can never be deleted. An issuer can pre-authorize a trust line with the setAuth flag only even if the limit and balance of the trust lines are 0. So an authorized trust line can never be deleted from issuer end as there is no clear or unset flag associated with setAuthrized flag. But it can be removed or deleted from user end, and I'll show how to do that. Let me comment this. But while we uncomment these lines of code, let us authorize a random account which doesn't even have a trust line set up with the issuer. So let's authorize a random address. Now in this case, the user, in this case, this address has not established a trust line with the issuer. But still the issuer authorized this address to hold the balance. So since the user here is in default state, the issuer pays for this trust line. So let's see. As you can see, the owner count is 1 here because the user account is in default state on this trust line. Let me comment the whole code here. And then check the account lines on this user account. So there will still be a trust line information associated with this user even though this user is in default state. So let me bring up that trust line information. This account has a lot of other trust lines. So this is the trust line wherein the user is in default, but the issuer is not because issuer set this peer authorized to true. Now the issuer has no means to set this peer authorized to false, but still this trust line can be deleted from the ledger from user end by just again setting the user end to default. The user end is already in default state, but still the user has to execute the code to set itself to default state once again, and that trust line gets deleted. Now let's get back to our user account and set this to default state and just remove this trust line from the ledger. For this to happen, the balance should be 0. That's the first requirement. So let's send back the balance, that is 1 XTP, to the issuer. So from user account, this is the user account's family seed or secret. This is the R address of the issuer. So send back the XTP. So the first requirement is to have 0 balance of the issuer issued currency. Okay. Now let's set everything, all the configuration to default from user end. So let's copy the flags from TrustSet transaction. So let's first copy this clear freeze. If by accident you set freeze on your own account, let's clear that freeze first. Let me even copy this clear no ripple. And then set no ripple. Oops. Now let's use flag names package. I have already installed it. I'll just copy the syntax from here. I have even imported it in my script. I'll declare a constant. It's an array, by the way. This flag names returns an array, by the way. So first, clear the freeze, and then inside the bracket, you have to put this bracket or else the results will be wrong. Now, if this flags constant, it's an array. If that array includes or has this flag or this element, which is LSF default ripple, which means rippling enabled on account level. In that case, clear no rippling on the trust line. If default ripple is not there, not present on the account, then set no rippling on the trust line. Now let's even set quality in and quality out to 0. And let me replace this with the actual issuer address. That's it. And the very important thing is this value should be 0. Should be 0. Okay. So this is all the configuration you need to be in default state from user end and to remove the trust line even with authorization true. So let's submit this to RippleD and see if the trust line gets deleted or not. This sequence number has already passed. User, this is being executed from user end. So we have user.address here, which is correct. And then, oh, this has to be user.address as well. I think everything else is correct. Now let's execute this once again. And the transaction was successful. Now the important part. Let's see if the trust line got deleted or not. Let me comment the whole thing here. And then execute account lines command on the user account. And as you can see, the authorized trust line got deleted. And this is the same logic you need to run from user end, even if your side is completely in default on this trust line and issuer somehow authorized your address to hold the balance. Still, issuer can't do anything to delete this trust line, right? There is no unset or clear set authorization flag or anything for the issuer. So the user, even though user is completely in default state, the user should execute this same logic and the trust line will be deleted from the ledger.